As per the problem, there is a wire of length 2L and which is stretched between two pillars. So this is first pillar, this is second pillar. Okay, between that pillars, this wire is stretched like this. This is the initial position. We can consider the wire as AB. It is in horizontal direction initially. Now some mass, that is mass m, is suspended at the midpoint of the wire. So when you suspend this mass at midpoint, the final position of the wire will be like this. So I will name this as C and ACB. So now ACB is the final position of the wire. Due to its weight, due to this weight, what happens? This wire moves down. So this is the displacement, x is the displacement. So due to this weight or due to this mass, this wire gets stretched, or there will be some elongation produced in this wire. So whenever there is some elongation, there must be some strain. So as per this problem, you need to calculate that strain. Okay, so you know strain equal to change in dimension to original dimension. Here we are talking about elongation, therefore you can consider longitudinal strain, that is delta L divided by L. So change in length to original length. Original length here it is given as 2L. So 2L is the original length. Okay, now delta L we need to calculate first. So delta L that can be given as final length minus initial length. So change in length is nothing but final length minus initial length. So what is final length? So now here ACB, correct? No? So this ACB is the final length actually. So A to C and C to B. So we can write final length as AC plus CB, that is the final length. And what is the initial length? That is AB. AB is the initial length. Okay, so that is delta L. Now if you look at this diagram, this AC must be equal to CB, no, because this is suspended, this mass is suspended at midpoint, therefore AC must be equal to CB. So I will write this CB as, this CB can be written as AC itself, therefore AC plus AC. So what do you get? AC plus AC, that can be written as 2AC minus this is AB. AB is equal to 2L, original length. So I will write this as 2 times AC minus 2L. Okay, so that is delta L, or you can take 2 outside. So AC minus L. Okay, that is delta L value you got. Now this AC, from this diagram, just look at this. AC is here. So now if you look at this triangle, this one and this one similar. So this is actually right angle triangle. No, I will rewrite this. Okay, this is O, this is A, and you can write like this. So this is actually C, point C. Now this triangle, if you consider, this is equal to 90 degree. And actually what about length AO? Actually total length is 2L, and this is the point. You can consider this point as O. Okay, I will consider that as that point as O. So that is midpoint. So total length is 2L. Therefore A to O you can consider length as L. No, A to O, the length equal to L. This length is L, and here also this length is L. So now you have this AO, that is L, and what is OC? OC equal to X. So this is L and this one is X. I think now we can calculate this using Pythagoras theorem. So what do you get? AC square or AC, that is equal to root of AO square plus OC square. AO square plus OC square. So just substitute the values. So what do you get? AO square plus OC square. So we get AC, that is equal to root of AO is nothing but L square plus this is x square. Now you can substitute this value of AC in this equation. Okay, so if you substitute that, you will get delta L, that is equal to 2 into root of L square plus x square minus L. Okay, now delta L equal to 2 into, I will take this L square outside square root. So if you take L square outside square root, so before taking outside square root, I will just take that L square outside from this. So how you can write square root, I will take L square outside, inside only. Okay, L square into 1 plus x square by L square, like this we can write, no? I am taking just L square outside from this expression, then I can take that outside to that square root, outside of that square root. Let's look at this. So now I am taking this L square outside square root, so that is 2 into L square, so remaining terms are 1 plus x square by L square, that is inside square root. Okay, so this, so now if you take L square outside, that becomes L, that will be equal to L. Okay, so now this L and this L, it is common, so 2 into L into 1 plus x square by L square to the power half minus, that becomes 1. Okay, now this term, that can be solved using binomial expansion. So what is binomial expansion? 1 plus x to the power n, that is equal to 1 plus nx plus n into n minus 1 into x square divided by 2 factorial, like this it goes. So we can neglect these higher order terms, so we need to consider only first terms, these terms. Okay, need to consider only these terms. Okay, so if you look at this here, so instead of this n, you have half, it is 1 by 2, and instead of this x, you have this term, that is x square divided by L square. Okay, therefore if you rewrite this expression delta L, it becomes 2L into what happens, 1 plus n, n is nothing but half. Okay, 1 plus n half into x is nothing but x square by L square. Okay, so that one minus, what is that, is 1, minus 1. So this plus 1 and minus 1 can be cancelled, and this 2 and this 2 can be cancelled, and 1 L can be cancelled from this, so 1 L remains. So finally you get x square by L, that is delta L equal to x square by L you got. Okay, so that is delta L. Now what we need to calculate? We need to calculate strain. So strain equal to delta L divided by original length. So original length is 2L. That means x square by L whole divided by 2L. So if you simplify, you will get x square by 2L square. So this is our answer, x square by 2L square. So if you look at the options, that is option number 2. Okay, x square by L square is the answer. Thank you.